Hi, and welcome to this unit on transformations. In this unit, we're going to look at a series of different types of transformations, including translations, which is what we're going to start with today, which are just shifts in your function. So just moves it left or right or up and down. And we're going to be looking at translations to x and translations to y, which tell us that our function is either moving horizontally or vertically. The other thing that we're going to look at is dilation, and that is going to change the magnitude or the size of our function. So it's going to either multiply or divide our function. And last, we're going to look at reflections, which are going to mirror our functions in a particular direction, either across the x-axis or across the y-axis, or around a point. Okay, and lastly, we're going to be looking at piecewise functions, and that's just a combination of different functions put together for certain domains. And then lastly, we'll look at transforming piecewise functions and then putting everything together. Okay, so this unit should be interesting. We've studied, I'm assuming that you have at least some background knowledge of transformations from Algebra 1, but the way we study them may be a bit different than what you learned in Algebra 1. Simply because we want to make sure that you understand what's happening when a function is translated. Okay, so translations is what we'll start with. So what you're going to do is the directions say graph each parent function, then use a calculator to graph each requested function in the table below. Describe the change in the graph, then sketch the graph on your paper. Select and circle one of the transformed graphs in the table to describe the characteristics for the following. So these characteristics that we're talking about will be x-intercepts, y-intercepts, domain, range, and vertex, asymptote, any of those things. So what you're going to do is you're not going to complete that for every function that you're going to transform, because you can see here you have 2 transform functions for the quadratic, you have 4 transformed functions. So you're not going to complete it for every one, but you're going to pick one of those transformed functions to complete those characteristics for. Okay, so let's get started. So I'm going to introduce you. You're going to use the calculator for this activity, probably for about the first 1 to 4 functions. So we have x squared, x cubed, and maybe by x fourth you'll have it. Some of you may need to continue on to x fourth. But you'll know what's going to happen to the function. Okay, so we're looking at translations and what could possibly happen. First off, we're going to graph the parent function. Our parent function in this case for the linear is f of x is equal to x. So you can call that y equals x. I really don't care, as long as you understand that your equation is just written in function notation when it's f of x. Okay, let's graph the linear parent function. The linear parent function is f of x equals x. So since I know that one, I'm going to assume that you guys know it because we've studied the parent functions before. And so we know that a linear function just has a relationship of 1 to 1. So I'm going to graph that one, and I'm going to leave it there. Okay. Next, it has some other functions that I want to compare it to. First off, I need to identify that this one is linear. It's the linear parent function. Okay. Now I'm going to graph a transformed function that's also a linear parent function. That's also a linear function, but not a parent function. So in this case, I'm going to pull up my graphing calculator because that's going to help me. Okay. So let me pull my graphing calculator into the window so that you guys can see it. And you may be able not to see some buttons, but that's okay. Okay, so first off, I'm going to go to my y equals editor, and then I'm going to clear out whatever's there. And yes, I already had some stuff there, but that was from another lesson. So first off, I'm going to type in x, graph it. Okay, make sure that I can see my parent function clearly. And now I'm going to graph the transform function with it. Okay, so I'm going to come and I'm going to graph x plus 2, which is what it's asking me to graph. So then I'm going to hit graph. And I can see what happens. The transform function is graphed above it. So it looks like it's up 1, 2 above the axis. Okay, so for this description, here I'm going to come and write when you add 2 to the parent function, it shifts up by 2. Okay, so then now let's look at what happens when you shift down. So I'm going to come back, use my calculator, go to my y equals editor. I'm going to leave that parent function there, and I'm going to clear it out, and now I'm going to graph x minus 2. Okay, so then I'm going to hit graph. There's my linear parent function that was there to begin with, the blue one, and now the transform function is actually below it. So it looks like it's been shifted 2 spaces down. Okay, so for this one, I'm going to write that when you subtract 2 from the function, it shifts down by 2. And you can write units, spaces, whatever you have room for. Okay? So what I want to do now is I want to pick a function that, that I want to complete these 4 characteristics for. Here it's only 4, but as your functions get more complicated, you have about 6 different characteristics. Notice that we add vertex and asymptote. Well, linear doesn't have any of those, and linear only has 2 cases because f of x is equal to x. Whatever you're doing to x, you're actually doing it to y, okay? So we'll see how that changes as we add more complicated functions. Okay, so for the linear, I can look at my graph. So I'm going to graph those 2 functions. I know that when I added 2, it shifted above. So each point on my graph shifted up 1, 2. This point shifted up 1, 2. This point shifted up 1, 2, 1, 2. Okay, so what I get is a line that looks just like the parent function, but that's above it. And when I subtracted 2, it shifted down 2. So down 1, 2. All points down 1, 2, 1, 2, 1, 2, and 1, 2. So in this case, and I'm going to actually graph this one in a different color. I didn't want to use blue for that one. See if I can erase that. Okay, what I get is a line that's below it. Okay, so when I do my characteristics, I think I'm going to use the x minus 2, f of x equals x minus 2 line. So I'm going to circle that one, showing that that's the line that I'm completing the characteristics for. Okay, so what are my x-intercepts now in the new function? I don't need for you to write the x-intercepts in the parent function. You need to understand how the x-intercepts and the y-intercepts and domain and range have all changed because the function is now moved. So I know that you know what they are for the parent function. But for the non-parent function, f of x equals x minus 2, the x-intercept in this case is 2, 0. Okay, and the y-intercept in this case is 2, so actually it's 0, negative 2. Okay, the domain and range, those didn't change. I still have the arrows in my function. Reading from left to right, it still goes from negative infinity, so negative infinity is less than x, which is less than infinity. And then for the range, it stays the same, right? It's still continuous from bottom to top. So from negative infinity is less than y in this case, because we're talking about all the y values in the range, which is less than infinity. Okay, so now let's look at the function for f of x equals x squared. What kind of function is this? Well, if you guessed quadratic, that's correct. This is a quadratic. It represents the quadratic parent function. So what I'm going to do is I'm going to go ahead and go back to my red, and I'm going to graph the quadratic parent function. Okay, so I'm going to go over 1, up 1, over 2, up 4. Okay, because I'm squaring those x values for the parent function. Well, the quadratic is going to behave a bit differently, okay, depending on what we do to it. So first, let's graph the case of x squared plus 2. So I'm going to go back to my graphing calculator, clear out what I had. And so now I'm going to put my new parent function in, x squared. Okay, then I'm going to go down, and I'm going to type x squared. And then in this case, it's going to be plus 2. Oh, where's my 2? There's my 2. Okay, so I'm going to graph. You can see first the parent function. That's the one in blue. And then now it's going to graph plus 2. X squared plus 2. So we can see that the function is actually shifted up by 2 spaces. So all the points on the quadratic have shifted up. So I'm going to go back to my graph and represent that in a different color. Okay, so I'm going to use blue. And I'm going to use the same color for up just because it's easier for me to see. So all the points have shifted up 2. This point, 1, 1 is up 2. So now it's 1, 3. Okay, and then 2, 4 is up. So now it's 1, 7 and negative 1, 7. Okay, so we can see that our function looks something like that. And actually that one should be a bit over there, over to the right. Okay, so I can see that the function is shifted up. So I'm going to describe it by saying it shifts up 2 units or spaces, whatever you want to call them. Okay, so then I can graph the one below it to see what happens. So going back, and then I'm going to come down, clear out what I don't have to clear out anything. I just changed the sign. So what happens when that's a minus? And you don't want to use the negative. Make sure you use a minus. Otherwise, it's going to multiply by negative 2, which is not the effect that you want to get. Okay, so I'm going to hit graph. And so what I see is there's my parent function again. And when I subtract 2, it looks like, oh, the function is shifted down. So all of those points on the graph have shifted down 2 units. Okay, so I'm going to go to my green again. And I'm using this one for down, apparently. That's what I started with, so I'm going to keep it. And every point is shifting 2 down. Okay, now it doesn't matter which number. Even if you're not using 2, this is what's going to happen to your function when you add a number or subtract a number. Okay, you can see we get these two functions. So this one shifts down 2 units. Okay, so now let's look at what happens when we add directly to x. So in the first case, we squared x and then added 2, and we squared x and then subtracted 2. What happens when we add 2 before we square x, and when we add 2, or we subtract 2 before we square the value? Okay, so let's look at it. X plus 2 and then squared. So how do we put this in the calculator? Well, let's go to the y editor, and let's clear out what's there. And so instead of writing x squared plus 2, I'm going to open up my parentheses and do x plus 2 first, and then square it. So 2 is being directly added to x. Okay, so let's graph that and see what it looks like. Okay, so there's the first one and there's the next one. So we can see that adding 2 before we square it actually shifts our function left. Okay, you would think because you're adding that it shifts it right, but actually anything that happens to x is always opposite. Okay, because x is in factored form, and if we were to take x plus 2, so for instance x plus 2 is x plus 2 squared. If I was to solve that factor, you know that x plus 2 squared is the same thing as x plus 2 times x plus 2, right? And if we set that equal to 0, then that would be x plus 2 equals 0, and so x would be equal to -2 in both cases. Okay, so that's why it actually ends up being -2. It shifts the function left to -2 instead of right to +2. So when we add 2 directly to x, or you add any number directly to x, it's going to shift the function, it's going to shift left. And in this case, because the number is 2, it's 2 units. Okay, so what do you think is going to happen when we subtract 2? So let's look at it. Let's go back to our y editor, and I'm going to go down and change that minus sign and that plus sign to a minus sign. Make sure you don't change it to a negative, but that you change it to a minus, because if you change it to a negative, it's going to multiply it and cause your function to be incorrect. Okay, so let's graph it. Oh, okay, so there's our parent function. And if you guessed that it shifts it to the right 2, then you were correct. Okay, so subtracting 2 directly from x shifts your function to the right 2. So it's going to shift right by 2 units. Okay, so let me graph those two functions that I just did. First off, I'm going to graph the one that shifts it left. So that was the plus 2. So 1, 2, every point will move over 1, 2 from the parent function. 1, 2, 1, 2. Then here, 1, 2, and then here, 1, 2. Okay, so you can see how that has changed my function. All right, and then for the one that was supposed to be -2, I'll do that one in black. So -2 actually shifted it right. So it went 2 spaces right. So every point on the parent function went 2 spaces right. And be careful not to get too confused, because it will be a bit messy because we're graphing everything on the same one. But it's just so that you guys can see all of the transformations. So all of the possibilities, all of the translations. Okay, so we can see that if we add 2 to x squared, it shifts up. We subtract, it shifts down. So when you do something to y, it does exactly what it is. But when you do something to x, it's the opposite. So when we add 2 to x, it shifts left. And when we subtract 2 from x, it shifts right. So you get all 4 of those functions. Okay, so I'm going to pick a function to find my x and y intercepts and domain and range for. I'm going to pick the function, I think, x plus x squared. I'm going to pick x squared, x plus 2 squared. I'm going to pick this one. Okay. So while you can pick the same one each time, I don't recommend that, because you want to get experience interpreting all the different types of graphs, all the different types of transformations. So if you just pick, for instance, if you just pick x minus 2, and then you come over here and pick x squared minus 2, then you're kind of gonna get the same thing every time, and you're only really getting experience with one function. But you need to be able to interpret these points for all functions and see how they're changing and see how the transformations change the function. So you should switch it out. So maybe go down the row. So maybe start with x minus 2 and then go to x plus 2 squared, and then next time go to x squared plus 2 and x minus 2 squared, or something like that. And it's going to be different when it's cubed into the fourth and blah, 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 blah. Okay? All right, so let's look at the x-intercept for this function. So the x-intercepts for x plus 2 squared. Well, x plus 2 squared shifted my function to the left, so I'm looking at this function here in gray. And so that is going to make my x-intercept negative 2, 0. Okay, so it's on the x-axis. In the case of the y-intercept, well, since it shifted over, the y-intercept is not the vertex anymore. It's not 0, 0. So the y-intercept is now 0, 4. And the domain, that pretty much stays the same. Negative infinity is less than x, which is less than infinity. And the range actually stayed the same because it did not shift up or down. Okay, so the range is still y is greater than or equal to 0, just like it is for the parent function. And then the vertex is actually now the x-intercept, so negative 2, 0. And then the asymptote, well, that doesn't apply to this function, so you can just put not applicable. Okay, so these are the features for the gray function. However, if we had studied the blue function, the one where it shifts up 2, we would have had no x-intercepts, and we would have had a different y-intercept. Or if you had studied the point where it shifted down, well, now we've created 2 x-intercepts, and the y-intercept is now below the x-axis. Okay, so I hope this has helped you. So you can go back through this video as many times as you need to, and the functions will get progressively harder, but just remember how we entered in f of x equals x cubed, and just remember to go back to lesson 1.4 that was on parent functions, so that you can, if you need help with the features and what type of function it is and how to write domain and range and x-intercepts and asymptotes and all that stuff. Okay, I hope this video has helped. Hopefully it wasn't too long, maybe it was, but you can go back and look at it as many times as you need to in order to help you graph the functions and complete the assignment. All right, good luck. And don't forget to complete the homework. When you complete the homework, while you can use the calculator for the actual lesson in class, remember you should be discovering the patterns, right? So you should see these patterns now. And so you won't need the actual calculator. So you should not be using the calculator on the homework. All right? Okay. Best wishes, and see you in the next video.